Hello, in this brief video I'm going to explain the truth table for OR, the OR symbol. And this is our last symbol we're going to be learning for a while, and it's also the last truth table then we're going to be learning for a while. Although we're going to be learning to do some other new things with truth tables soon, using them to evaluate arguments. But right now, it's the table for OR. So let's take a look. Well, not quite. Remember that OR is inclusive. So what does that mean about OR? Well, we know that P or Q, that's going to be true if P is true and Q is false. P or Q is going to be true if P is false and Q is true. P or Q is going to be false if P and Q are both false. And because it's inclusive, it's going to be the disjunction P or Q is true if both P and Q are true. So let's take a look at what that looks like in truth table format for any sentences, box and circle. If we're looking at the disjunction box or circle, then if both box and circle are true, then the whole disjunction is true. If box is true and circle is false, then the disjunction is true. If box is false and circle is true, then the disjunction is true. And finally, if they're both false, then the disjunction is false. So the disjunction is false only if both of its components are false. So they're in most situations, in most kinds of situations, it's true. So we can just apply this in a straightforward example. We have the sentence P or not P. That's a tautology. It's true in every situation. Let's see why. So let's consider the situation in which P is true. Well, okay, that means not P is false, but it also means that the whole thing is true. Why? Well, because its left disjunct is true and its right disjunct is false. That means we're on the second row of the truth table, and on that row of the truth table, the disjunction is true. What about when P is false? Well, that means that not P is true, and so the left disjunct of the disjunction is false, and the right disjunct of the disjunction is true, and so the whole disjunction is true. So P or not P is true in all situations. It's true no matter what. It's a tautology. It would be nice to be able to do a derivation of P or not P from no premises to show that it's a theorem. Up until we introduced indirect derivation, we would not have been able to do a derivation of this theorem. And in fact, there are lots of theorems that we need indirect derivation to do, lots of arguments that we need indirect derivation to do derivations of. And so we'll be seeing how to do a derivation of this argument or of this sentence, getting more familiar with indirect derivation as we proceed. But this is the truth table for OR. It's true on all rows of the table except on rows where both disjuncts are false. So, good luck with your work. Let me know if you have any questions.